Okay, everybody, let's get going on our final problem, like what we've been working on. So again, we're trying to show that the triangles are similar either by SSS similarity, AA similarity, and SAS similarity. So one of those will hopefully show that these two triangles are congruent. Now, looking at our picture, we kind of have two triangles going on. We got this smaller triangle, and then we have this larger triangle. So we kind of have two overlapping triangles. So that is going to make things a little bit more challenging, which if you guys see, I split up the two triangles over here. I broke it into our smaller triangle, DEH, as well as our bigger triangle, DFG. Because sometimes when we have triangles overlapping other triangles, it starts to get really confusing, so sometimes it helps to separate them. So I've separated them to help you guys see it a little bit better. Okay, well, let's get going. So again, in this picture currently what I have, we have some congruency marks. Like in example 9, I don't know what the side links are. So I'm just going to assign them whatever I like. Since these two are the same, I'm just going to, I'm going to assign them 4. And since these two are the same, I'm going to assign them 2. Okay, so looking at my smaller triangle, I know that DE is 2, so DE right here will be 2. And I know that DH is 4. Now the big triangle, this is where it gets a little tricky. The big triangle is this entire side length. So DF is that whole thing. So if this part is 2 and that part is 2, how would I find the length of the whole thing? So DE is 2, EF is 2. How do I find DF? That is correct, you guys. In order to find the whole side, I need to add these two together. So if I add the 2 and the 2, that will give me the whole side, which is 4. Okay, so I currently know that DF is 4. And same thing with this side. So DG is the whole side, which on DG, I know that DH and HG are both 4. So what do I do with the 4 and the 4 to get the entire side length? Holy hot dog. I would add them together as well. So let's see here. I'm going to add the 4 plus the 4, which gives me 8. That says 8. Guys, so I now know that this whole side is 8. Guys, so if you ever have like overlapping triangles, usually the way that you get the side length of the big triangle is by adding up all the pieces. So just keep that in mind. Okay, so if we look here, I have two sides that were given to me in my picture. Now, there isn't an SS similarity. There is an SSS similarity. There's also an SAS similarity. So I know it has to be one of those two. So I might have to use one of those up my sleeves to find the missing either angle or side, depending on if I go the SAS route or the SSS route. Okay, well, let's get going, you guys. So I'm going to start with 2 of my side links. So I'm going to start with my scale factor. Okay, so these two, DE and DF, correspond. So I'm going to divide DE by DF. So D to the E is 2, and DF is 4. And I can reduce this down. So 2 divided by 2, I can divide each of these by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. Guys, so my first scale factor is 1/2, which it was given to me. Okay, now I know technically I have 2 other sides that are possibly proportionate. We'll have to see. But before that, there's already a trick up my sleeve that I can use to mark one of my angles in my picture as congruent. Now looking here, if we look at triangle DFG, so the big triangle, see DFG, and then if we look at the little triangle DEH, so this is the little triangle. Okay, so we got the little triangle right here, and we got the big triangle right here. So we're looking at triangle DFG and triangle DEH. Do you guys see, is there an angle that is in common between my two triangles? Do you guys see it? They both have angle D in it. This triangle and this triangle both have D, so they both have a shared angle. So I can mark an angle D as congruent in my original picture like that, or I can mark it separately when I separate the triangle. So I know for a fact that angle D is congruent to itself, angle D. Okay, so when we have a shared side or a shared angle, or we say something is congruent to itself, what is that nifty property we use? Awesome job, you guys. It would be the reflexive property. You guys are so smart. Guys, so sometimes in our overlapping triangles, we will have a shared angle. So be on the lookout. That will probably appear again. Okay, so I have a side, I have an angle, and I have a side. Whoa, do you guys see now that SAS is creeping into my picture? I have a side, then an angle, then a side. Okay, so to prove that these two triangles are similar, by SAS similarity, I must show that my other two sides are proportionate. So we did side DE and DF. So now let's do sides DH and DG. Okay, so I'm going to do my last scale factor. Okay, so I did my smaller triangle over my bigger triangle. So my smaller triangle is 4 over my bigger triangle, which is 8. And guess what, you guys? I can reduce this fraction down. 4 will divide into each of these. Okay, which 4 divided by 4 is 1. 8 divided by 4 is 2. Whoa, do you guys see that our scale factors are the same? Yay! And this was also given to me, so I'm going to write because the given. So I have proven that two sides are proportionate and the angle in between the two sides is congruent. So guess what, you guys? These two triangles are similar by SAS similarity. So let's go ahead and write our similarity statement. So I'm going to say triangle, let's see here, I'm going to say HDE is similar to triangle. So if I go HDE, I go from my larger side to my smaller side to the side without anything. So if I go from my larger side to my smaller side to the side without anything, that would be GDF. So G to the D to the F. Oh, sorry guys. And I know that they're similar because of SAS similarity. Don't forget the fancy tilde. Well, that's it for those types of problems. The next ones we're going to do, we're going to be not only stating how the triangles are similar, but we're also going to use our similar triangles to solve for missing sides, which will be exciting. I don't want to give too much away, though, because I know you guys have been dying to learn how to do that all day long. So I'll teach you about that when we get there. So nice work, you guys. Nice job.